Hi, my name is Carly Pajak, and today we are going to be doing the Interactive Advanced Concept Presentation 5. We are going to be removing tarnish from pennies today, and we are going to talk about the reactions that occur when we do this. So first we'll start off with our supplies. We will talk about the experiment that we are going to be doing, and then we will go over the equations that break down the chemistry behind it. So, we have our pennies that have tarnish on them. We have salt, white vinegar, and we were also asked to pick a control for this experiment, and so mine is just water. And I have my dishes. One will have water and one will have vinegar in it. So the first thing that we are going to do is we are going to combine the vinegar and the salt in one of the dishes. And we are going to form the sodium acetate and hydrochloric acid. So I'm not going to do any specific measurements here, just enough for the pennies to be submerged in the vinegar and add a decent amount of salt. So the salt is important here, and we are using table salt, which is NaCl, and we are doing this because the NaCl, the chloride that is in the NaCl, the chloride is going to be what reacts with the oxidized penny to remove the oxidation from it. So I'm just going to take a spoon here to dissolve all of this. Here we are making the the sodium acetate and the hydrochloric acid. It's important that we mix this up because, like I said, the sodium chloride, the salt, has to react with the acetic acid, which is our vinegar, in order to form the hydrochloric acid, which is going to remove the tarnish from the penny. Okay, so I'm going to save a couple of these pennies to put in our water substance here, but we'll go ahead and drop our pennies into there. Give this a spin, and we're going to let those sit. Okay, I'm going to take my other dish here. We're going to just use water and salt this time. So this is a control because the sodium chloride from the salt is not able to react with the vinegar to form the hydrochloric acid. So this is just salt water for us here. We'll give this a stir as well. Okay, now we're going to drop our pennies into here. And while these sit, this is my vinegar, this is my water, we will go over the equations. So we'll start with our first equation here. We have our vinegar and our salt, which is our CH3COOH, aqueous, it's our vinegar. And we have the NaCl, which is a solid, salt, table salt, sodium chloride. These mix together to form the sodium acetate and the hydrochloric acid. The hydrochloric acid is what is needed to remove the tarnish from the pennies, which we will see in our next equation here. So this would be after the salt is dissolved in the vinegar. This next equation is what happens whenever we remove the tarnish from the pennies. So this is our copper oxide, which our penny, which is made out of copper, when it is exposed to the oxygen in the air for a long period of time, is when we see the oxidation occur, or the tarnish that's on the penny. So the hydrochloric acid is going to be what removes this. So copper oxide, CuO, solid. This is the tarnished penny, and we have 2HCl aqueous, which is our hydrochloric acid, which came from our last equation here. This comes together to form copper 2 chloride in water, which is what is left over in our dish here. So I'm going to give this another spin before I take these out and dry them off. So they might not be 100%. I might have needed to add more salt or maybe more vinegar. But let me dry these off and we will take a look at them. Some of it is coming off onto the paper towel here when I rub it as well. So, not 100%, but definitely a lot shinier than what we had whenever we first started. So set these here, and then we'll move to our water and salt mixture. I can see immediately, even before drying them off, that they're about the same. I'm not picking up any residue from the paper towel either. Yeah, these are definitely exactly the same as they were whenever I put them in. So this was an acid-base reaction. It's also a neutralization reaction and a double displacement. As we were able to see on our equations here. So just in the first one, the acetic acid and the sodium out of the, or I'm sorry, not the acetic acid, the CH3COO mixed with the Na to form our sodium acetate. The hydrogen in our acetic acid formed with our chlorine, or I'm sorry, our chloride and the salt to form our hydrochloric acid, which comes over to our next equation. Hydrochloric acid comes together with our copper oxide, our acid base, double displacement, neutralizes it, removes the tarnish or oxidation from the penny in order to give us shiny new pennies left over in water. So this was the Interactive Advanced Concept Presentation 5, and thank you for watching.